Okay, today we got Unit 4, Topic 5, which is all about stoichiometry, or specifically some stoichiometry with solutions. So we're going to be writing net ionic equations, doing some molarity calculations, and so today we just have one practice problem. This will be the first in a series of videos on different types of calculations we can do with solutions. So let's jump right into it. So we're going to calculate the concentration. So anytime we're, say, concentration, we're going to find molarity of 45 milliliters of a phosphoric acid solution that neutralized 20.8 milliliters of 0.532 molar sodium hydroxide, and we're going to assume complete ionization of the acid. So remember, our strong acids, if we assume their complete ionization, we're just going to have a one-way arrow. So we're going to write our net ionic equation, or our ionic equation. So we're going to have phosphoric acid is H3PO4, and that's aqueous because it's a solution, plus our sodium hydroxide, which is Na, and then OH, and that's also aqueous. Oops. And then that yields, so remember, water is always going to be a product of one of our strong acid and base reactions, and that's going to be a liquid. And then our other product is going to be the salt, so it's going to be sodium and phosphate, but there's a charge of -3 on this phosphate, and our sodium usually has a charge of +1, so we're going to need 3 of those. And we have PO4, AQ. We'll move this guy, sorry, he's in the way. And then just to balance, we have 3 sodiums on the product side, so we need 3 on the reactant. And then we have 6 hydrogens over here and only 2 over here. So just throw 3 out in front, and then we're balanced. So now we need to calculate concentration of the phosphoric acid, but we know our moles of sodium hydroxide. And you might say, well, how do we know the moles of our sodium hydroxide? But we know the moles of sodium hydroxide because we know that molarity, so our M, capital M, remember, is equal to N over L, where this is our moles. And if we know any 2 of these, we can solve for the other 3. So we know our molarity of our sodium hydroxide was 0.532 molar. And then we know that there was 20.8 milliliters, but this is in liters, so we need to move the decimal place over. So we have 20.8 milliliters, which is equal to 0.0208 liters, because we moved the decimal 1, 2, 3 places. And so to get this on the other side and solve for moles, to get this liters, we're going to multiply by L, and so we're going to get M times our liter value, which is 0.0208 liters, which equals our moles. So our number of moles is going to be equal to 0.532 times 0.0208, which equals around 0.011 moles of NaOH. So if you guys are looking at problems and you're saying, oh, well, I don't even know where to start, always start with what you have and know that you need to get into moles. If you have 2 of these quantities for M equals N over L, we can solve for the other 3. If we have the number of moles and the molarity, we can solve for liters. If we have the liters and the molarity, we can solve for moles. So first step should always generally to get into moles, so that way it's easy to work with. So we have moles of sodium hydroxide, but now we need moles of the acid. So that's why we wrote out this net ionic equation. Sorry, it's getting a little cluttered. I'll move down, but so we can look at our molar ratio. So we're going to start with our 0.011 moles of NaOH, and then we're going to multiply that by, for every 1 mole of the acid, because this has a imaginary coefficient of 1, we're going to convert 1 mole of H3PO4 and then that's over the molar ratio. So for every 1 mole that reacts, we're going to have 3 moles of the sodium hydroxide. So we're just going to divide our mole amount by 3. Sodium hydroxide, so NaOH. And that equals, so you just divide that by 3, and we get 0.0037 moles of H3PO4. And at this point, now that we have our moles and we have our 45 milliliters of the solution, we know that molarity, again, I'll write it out this time just so everyone knows. I know this is kind of a new concept. We haven't ever talked about molarity before, but we know that it equals N, which is our number of moles. So we have 0.0037 moles over our concentration. And remember, since we're dealing with small amounts in chemistry, we usually always use milliliters, but we need it in liters. So we're going to move this decimal place 1, 2, and 3. So we're going to 0.045 liters. And that's going to equal a 0.082 molar solution. So we use capital M, solution of our H3PO4 that was required to neutralize the 20.8 milliliters of this 0.532 molar concentrated sodium hydroxide. This was more of a simple one, kind of just tying in the molarity, but once we get into some more complicated problems, that's where we have more difficulty. So definitely let me know if you guys are struggling with this part. We can definitely get something worked out where we can do some more independent practice, and then just keep doing your homework and keep doing your practices. Okay?